A projectile is any body that is given an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. The trajectory, which is pink, is the path taken by the projectile. There are some basic concepts that apply to all projectile motion problems. Second, the velocity of the projectile in the x direction is the same throughout the entire time it is moving. As a result, the acceleration in the x direction always equals 0 meters per second squared. This gives us the equations a in the x direction equals 0 and vx final equals vx initial. The equation for the velocity in the y direction is vy final equals vy initial minus g times time, and the equation for the position of the projectile in the y direction is equal to y final equals y initial plus vy initial times time minus 1/2 gt squared. In order to get the position function of the projectile in the y direction, we need to use calculus. We know that velocity is equal to dy over dt. When we multiply dt by both sides, we get dy is equal to v times dt. Earlier we found that vy final equals vy initial minus gt. When we substitute that in for v, we get dy equals v initial y minus gt times dt. Then we take the integral of both sides of the equation. This will result in y final minus y initial equals vy initial times time minus 1/2 gt squared. When we simplify this, we get y final equals y initial plus vy initial times time minus 1/2 gt squared. The process for finding the position equation in the x direction is very similar to that of the y direction. First, we know that v equals dx over dt, and we manipulate it to get dx equals v times dt. Then we plug in the equation that we found above, which is dx equals vx initial plus at times dt. Then we take the integral of both sides, and that gives us x final minus x initial equals v initial x times time plus 1/2 at squared. Simplifying this gives us x final equals x initial plus v x initial times time plus 1/2 at squared. We know that a has no effect on horizontal movement and it equals 0, so when we plug that in for a, we get x final equals x initial plus vx initial times time. First, sketch a picture of the problem so that you can visualize what's happening. Third, list your knowns and unknowns. In projectile motion problems, these should include velocity, time, position, and acceleration. Finally, solve the equations for the unknown variables. First, we need to find the total time that the ball is in the air. Next, we need to find the maximum height of the projectile. This is a list of some of the knowns and unknowns. Here are some others. First, we solve for the initial velocities in the x and y directions. Because we know that the initial velocity is 20 meters per second and that we have an angle of 50 degrees, we can break it down into components. Using cosine, we can find the initial x velocity in the x direction because cosine is equal to adjacent over hypotenuse. We know that the hypotenuse is equal to 20 meters per second. So when we plug that in and multiply it by cosine of 50 degrees, we get an initial x velocity of 12.8557 meters per second. Next, we need to find the time that it takes for the projectile to reach its maximum height. We know that the velocity at the peak is equal to 0, so we use the velocity equation in order to solve for time. So we can plug in the values that we've already found. We know that the initial velocity in the y direction is equal to 15.321 meters, and g is equal to 9.8 meters per second squared. So we're able to plug those in, and we get 0 meters per second is equal to 15.321 meters per second minus g times t. When we manipulate that and set g times t equal to 15.321 and divide 15.321 by g, we're able to get t. Once we do this, we find that t is equal to 1.563 seconds. Next, we have to solve for the time that it takes the projectile to go from its maximum height to the ground. We have to use the position function because we don't know the velocity of the projectile right before it hits the ground. So we use the equation y final equals y initial plus v y initial times time minus 1/2 gt squared. And then we plug in the values that we know. We know that our y final is going to be 0 because our ground is at 0. We know our maximum height, which is y initial, is equal to 111.9734 meters. Our initial velocity is 0 because that's what the velocity is at the projectile's maximum height. We don't know our time, and we know that g is equal to 9.8 meters per second squared. When we solve that out, we get 111.9734 meters is equal to 1/2 gt squared. And then we find that t squared is equal to 22.8517 seconds squared. When we take the square root of that number, we find that t is equal to 4.7803 seconds. We also need to solve for the final velocity in the x direction. As we previously stated earlier in the video, the velocity in the x direction doesn't change, so our initial velocity will equal our final velocity. As a result, we know that the final velocity is equal to 12.8557 meters per second. Finally, we have to solve for the total displacement in the x direction. We use the equation x final equals x initial plus v initial x times t plus 1/2 at squared. Then we plug in the values that we already know. We know that x initial is equal to 0, v initial x is equal to 12.8557 meters per second, time is equal to 6.343 seconds, and acceleration is equal to 0. This gives us x final equals 12.8557 meters per second times 6.343 seconds, which equals 81.5476 meters. We thank you for watching our video, and we hope that it helped you learn more about projectile motion.